Today we are going to discuss with the concept called uncaught exceptions, try and catch. In the last video, we have come across with what is exception handling and why we are using that exception handling and what are the different types of keywords we are having in that exception handling, right? So here, today I'm going to differentiate things like, so how we are writing a program without using the exception handlings and with the usage of this exception handlings. So if you observe the first program, so this is the program which I'm going to represent without the exception handling concept. Okay. So here I'm going to define a class called a test try catch, and here this is my method main. Okay. So here I'm going to just specify that variable called data with the data type integer, and just I'm going to give the specification like 50 by 0. Okay. So generally any number that is divisible by 0 is undefined, right? We'll be getting an exception over here, but I'm not at all throwing any exception for this statement which I have represented. Okay, and then again I'm just writing this statement called printout statement, that is rest of the code. Okay, so if I run this program, definitely it will throw an exception like arithmetic exception. So why? Because here I have just represented that number which is divisible by 0. Okay, so if any number that is divisible by 0 is nothing but an undefined one. So here we will be getting an arithmetic exception if we run this program. Okay, see here if you observe the output, it has been represented like arithmetic exception. Why? Because the number we are giving is 0 over here. For the same program, I'm just trying to apply the exception handling concept. Okay, so here I'm just defining a class, and then here I'm representing the try and catch keywords. Okay, so here we are trying to handle the exceptions. So for handling this exceptions, here I'm just specifying declaring this integer called data with the type of integer, and I'm giving the value like 50 divided by 0. Okay, so if it is coming across with this statement in the sense, then it will go to the cache, so where it will be printing the exception called arithmetic exception. So in the last video, I have just clearly explained that if you try to handle the exceptions in this sense, it will go and it will execute the remaining code also. So if it is not handled in the sense, that is, the program will get interrupted over here and it will come out of the program. Okay, so if we are trying to handle the exceptions here in the program in this is, so whatever the rest of code we are having, or even after the exception occurs, it will get executed, but not without the exception handling. Here, as soon as after reading the statement 50 divided by 0, so as soon as the exception has occurred, it is going to interrupt that execution of the program, and it will be coming out of that program, and it will be displaying the exception like arithmetic exception. Okay, so whereas if we are trying to handle the exception in the sense, here after, even though it has been occurred with the arithmetic exception, it is going to execute this remaining steps of that program. Okay, so if you try to run this program here, the output will be like, it is going to display the arithmetic exception along with this one. So it is going to print the statement of rest of the code also. Okay, so this is the main difference between the handling of exceptions. Here, this is a without exception, no? So that means in the middle of the program itself, the program got interrupted and it came out of the program and it just displayed the exception. If we are trying to handle the exceptions means, so even after occurring the exception, the rest of the program is going to get executed and it is going to print the statement. Okay. So this is with the usage of exception handling. Next concept is internal working of Java try catch block. So in this previous example which we have seen, I have represented the try and catch, right? So in the try, I have declared the variable. In the catch, I have just mentioned the arithmetic exception. No, that means I have just specified which type of exception it is. Okay, so if you observe this diagram here, I'm just going to specify that whatever this statement which has been mentioned in the previous program, the same statement I have taken, that integer data is equal to any value divided by 0. Okay, so how it is handling? So I'm just saying that if we are trying to handle the exceptions, it is going to execute the rest of the code also. No, so here how this Java is going to, that means try and catch is going to handle this situation. Since the Java virtual machine firstly checks whether the exception is handled or not. Okay, so after noticing this type of statement, Java virtual machine firstly checks whether it has been handled or not. That means whether the statement has been, that means whether the exception is handled or not. If exception is not handled, it will come to this side. Okay, so JVM will be providing a default exception handler that performs some tasks. Okay, so JVM, if this exception is not handled, in the sense JVM is going to perform some tasks. So first task is it is going to print out the exception description. Okay. Next, it is going to print the stack trace. That means the hierarchy of the methods where the exception has occurred. So it is going to print the hierarchy of the methods, okay, where the exception has occurred. And the last one is it is going to terminate the program. If it is not handled in this, it is going to do all these 3 steps. So this is what we have discussed in this program. As soon as the exception has occurred, the JVM is going to check whether it has been handled or not. So it is not handled in this program. No? So what it is doing? So it is going to print the exception description. What type of exception here it is? It is arithmetic description. No, so it is going to print that one. And it is going to print the stack trace. So where it is existing in, it is existing in the main method. No, so that's why exception in thread main, it has recommended. Then after displaying these two, it came out of the program. That is, it is going to terminate the program. So that is what it is happened in this example. If it is handling this exception, okay, so if it is handling the exception analysis, then it will comes into this flow. Okay, so it will handle the exception and it is going to display the arithmetic exception, the type of the exception that has been occurred, and it is going to execute the rest of the code. Okay, that is what happened in this example. So here also the same exception it has been occurred. Okay, so it has been occurred with the same type of arithmetic exception. Even though after printing this arithmetic exception, it is trying to execute the rest of the code, and it is printing that statement. Okay, so this is how this internal working of the try and catch block will be done in this handling the exception. Next, Java multiple catch exceptions. See, we are going to represent try and catch now. So for a single try, we can have multiple catches. So in some cases, more than one exception could be raised by a single piece of code. Okay. So in some cases, more than one exceptions could be raised for a single piece of code. So to handle this type of situation, we have to specify 2 or more catch classes. So each catching a different type of exception. So when an exception is thrown, each catch statement is inspected in order, and also the first one whose type matches that of the exception is executed. After one catch statement executes, the others are bypassed, and the execution continues after the try and catch blocks. See, if more than one exception has been raised in the series, then we are coming across with the concept of specifying the more than one catch. Okay, so firstly, whatever the exception we are getting, so for that exception we are going to define the first catch, and whatever the remaining exceptions we are having in a serial order, that means in a sequential order, we are going to specify the catches over here. That means we are going to represent the exceptions. Okay, after bypassing all these caches, then it is going to execute the remaining code of the program. So I'll just explain the multiple catches through a simple example. Okay. So same example I'm taking here in this try block, I'm going to represent integer a is equal to new int 5. That means it will be the array a is specified with the values of 0 to 4. Okay. So with the size of 0 to 4, the array values has been specified. Okay. Then I'm going to insert the value called fifth place of array with the 30 by 0. Okay, so here it has been occurred with the three exceptions. Okay, so 30 by 0 is the arithmetic exception, and as I'm representing a of 5, it is denoting this out of bounds exception, and this normal exception is nothing but a so considering all the subclasses exception. Okay. See, if you come across this statement, cache arithmetic exception. Okay. So this cache arithmetic exception is nothing but which is related to the value called 30 by 0. So this is the first arithmetic exception. So for that one, I have defined this one. And also we are having the another exception called, see, I have defined the place called array with the 5 elements 0 to 4, but I'm trying to insert the value in the position of 5. Okay, so that means it is reaching the out of the bounds. Okay, here I'm just able to represent 0 to 4 only, but I'm trying to insert the value in the place of fifth value. So it is out of the bounds of array size. No, so that's why it has been represented with array index out of bounds exception. This is the second exception. See, in this simple piece of code, it has been arranged with the three exceptions. For the first exception, I have represented like arithmetic exception. For the second exception, I have represented like a array index out of bound exception. And coming to this cache exception, E is nothing but this is the common exception. Okay, for all the exception classes or subclasses of this exception. No, so this is an exception class. So this will be consisting of all the exception classes. So instead of catching multiple specialized exceptions, so we can just simply catch this exception class. See, 0 is an arithmetic exception, and if we are going to specify the more size in this is, then it comes under the array index out of bounds exception. No? So these are all the subclasses of exception. So instead of representing all the exceptions, here I am going to represent commonly, that means a single, simply a class called exception class over here. Okay, so even after performing all these catches, it is going to execute this statement also, then it will be coming out of the program. Okay, so this is how we are doing the multiple catches. Okay, so in the previous program, we have just represented one try with only one catch. But so within a single piece of code, if we are getting more than one exception in this sense, we are having an option to denote more number of catches, that is multiple number of catches for a single try. That is a simple example for multiple catch exceptions. Next one is nested try. Okay. So now we have gone through this multiple catch. Now I'm going to explain the nested try. Okay, that means try within the try is nothing but a nested try. Okay. See, the try statement can be nested. Okay. So that means try statement can be inside the block of another try. So each time when a try statement is entered, the main context of that exception is pushed onto the stack. If an inner try statement does not have a catch, okay, so if the inner statement is not having a catch in the sense for a particular exception, then the stack is unbound and the next try statement's catch holders are inspected. That means, see, I'm having here I have represented two tries. No, so if this try is not having this catch in the sense, then it will move to this try, next try, and then it is going to handle this catch exception. Okay. So this will continue until one of the catch statements succeeds, or else until all of the nested try statements are exhausted. Okay. So this is how this try is going to see, if no catch statement is going to match in the sense, then the Java runtime system will handle the exception. See, for each and every here, for each and every try, I have represented the catch, excluding this one. Okay. So for the nested try, no. So for the inner tries which we are having, I have represented the catch. For example, if I haven't mentioned the catch for this try in the sense, it will try to run this catch first. If it is okay with the same try block in the sense, then it is going to run. Otherwise, the Java runtime system will handle the exception. Okay, so I'll just explain you through this example. See here, I have just represented the try, okay, outer try, and then within that try, so I have represented the arithmetic exception. In the same way, I have represented the arithmetic bound exception. Okay, so here itself, as I have mentioned that variable declaration also, so it is going to run that statement. Okay, it is going to run that exceptions, and in the same way, it is going to do the remaining program also. That means it is going to execute the remaining code. Okay, that means there will be the normal flow of the statements from here to here. Okay, in case if we are not having, see, whatever the program, this is nothing but the arithmetic exception, and this is nothing but the array index out of bound exception, and this is nothing but the normal simply specified exception which is belonging to this try. Okay, so for each and every try, I have mentioned the catch over here. If I'm not mentioning any catch block in this try block in the sense, if no catch statement is going to match in the sense, then by default the Java runtime system will handle the exceptions, and it is going to terminate the program. Okay, this is with the nested try block. Next, with the finally block. So this finally is a block, so which is used to execute the important code such as closing connection and strings, etc. So here, in the previous lectures, I have explained as an example in reading and writing console inputs. There I have created a file. Okay, I have opened a file and I have done some operation for that file, and then I have closed that file. While closing that file, we will be making use of this finally block. So I have clearly explained that in the previous lecture. Okay, so here I'm just going to specify what is this finally block is meant for and how we are using that in exceptions. Okay, so in Java, so finally block is always executed whether exception is handled or not. Okay, so we are having this finally block in the sense, even though we are having the number of exceptions, whether it is handled or not, the final block will get executed. So why? Because this final block is always follows with the try and catch block. So it is existing in this sense, even though the exceptions are handled or not. So the final block is going to get followed by this try and catch, and it will get executed. So this is nothing but final block. Next with throw keyword. So throw is one of the important keyword, so that comes with that is used for mainly in exception handling. Throw and also the throws. Okay. So far, so we have been catching the exceptions that are thrown by the Java runtime system, right? However, it is possible for our program to throw an exception explicitly using the throw statement. So the general form of throw is so throwable then instance. So once a throwable or a subclass of a throwable is a primitive type where we can define this exceptions over there. That means usually we are having the two types of throwable objects. So one is with using a parameter in a catch class, or else creating one with the new operator. Okay, so that what will get happen? So the flow of execution stops immediately after the throw statement. Any subsequent statements are not executed, the flow of execution is going to stop immediately after the throw statement. So any here the nearest enclosing try block is inspected. So to see if it has a catch statement that is going to match the type of exception. If it does match, if it does find a match in the sense, control is transferred to that statement. If it is not matching in the sense, then the next enclosing try statement is inspected and it is continued. So this is how it is going to handle the, it is going to throw the exception by making use of this throw keyword. So here throw is used to explicitly throw an exception. So this throw exception can be done either with the checked exceptions or else with the unchecked. That is during the compile time or else at the runtime. So generally we are going to specify this throw like throw and then exception. Next, so if for example, if you want to represent it like a statement in a sense, then we are representing like through new IO exception. Sorry, if that means whatever the statements we want to print, that statement we can comment. Okay. So this is a simple program. So public class test throw one. Okay, and then here I have specified like if age is less than 18. It has to throw an exception, like throw new arithmetic exception not valid. That means if I'm going to pass any value, that means if I'm going to pass the value in the place of age like something 12 or 13 in this sense, then it needs to throw an exception like not valid. Okay, if it is okay, if it is okay in this sense, then it will come into this statement and it is going to print a statement called welcome to vote. Okay, so here I'm just passing it. I'm just going to check whether this condition is okay or not. So for that one, I'm passing the value called validate 30. So what it is going to do? So it is going to check the condition, like see validate in the sense it is a method. No. So here I'm just passing integer age. Where is the age I have specified in the if condition? So what is the age value over here? 30. So 13 is less than 18 or so it is less than no. So that's why it is going to throw an exception called not valid. Okay. So after throwing the exception, so it won't enter into this else statement or else the print statement over here. Why? Because it is throwing an exception through based on this condition over here. So it won't enter into the remaining things. Okay. So this is with throw. Okay. So we are just trying to throw an exception. So wherever we want. Next, throws. So here, if a method is capable of causing an exception that it does not handle, so it must be specify the behavior of the callers of the methods. Okay. So see here, so throws is also a keyword. Okay. So it is a capable of causing an exception and that it does not handle. Okay. So it must specify this behavior so that callers of the method can protect themselves against that exception. Same like throws, we'll be making use of the throws also. But here what we are trying to say, whatever the exceptions it can't able to handle, so that type of situations also we are going to protect them by making use of this throws keyword. Okay, so that it is giving an information to the programmer so that may occur an exception, so it is better for the programmer to provide the exception handling code so that normal flow can be maintained. Same like throw, we are throwing an exception over here now, but whatever the situations we can't able to handle the situations, in that cases we are making use of this protection. Okay. So this is an example for the throws. See here for the method itself, I'm just going to specify throws IO exception. Why? Because I don't know whatever the exceptions that will be going to get happen in this method. Okay, so what I'm trying to do for handling those type of exceptions by making use of those throws keyword, here itself I'm just passing the IO exceptions. Okay, so here I'm just making use of throw new IO exception. It's a device error. That means it is a checked exception over here. That means it is a compile time exception. Okay, and for the method n also, here I'm specifying the throws IO exception, where it is going to specify what are the, so whatever the exceptions that will occur during the runtime, it is going to handle this situation. Okay, so this is what the throws usage is meant for. Okay, so if you try to run this program, here we are having the representation called try and catch in the P method. Okay, it is going to, if even though the exception has been occurred here, so if any exception has occurred in the n method, in the sense it is going to execute this catch, okay, which is representing the statement called exception handling. Okay, so after running all this code, then it will be entering into the main method and it is going to execute the remaining statements. Okay, so this is how throws is going to get performed. It's the main difference between the throw and throws example. No? So today we have come across with the concepts like multiple catch, okay, and then nested try, and also throw and then throws. Thank you.